We're going to find the minors and cofactors of the 3 by 3 matrix given here. So remember how to calculate the cofactor for ith row and jth column. This is -1 to the power I plus j times the determinant of aij. So let us begin. I want you to pay attention to the first row. It has a 0 on it. So I'm going to use this row and write the expansion with respect to this row. The determinant of A is equal to the very first entry on the first row, first column, times the cofactor for the first row, first column, plus the rest of the terms. So let us do the calculation here. This is your matrix. The very first entry is equal to 0. Now, to get C sub 1 and 1, we're getting rid of the first row and the first column. We end up with a 2 by 2 matrix. Now, A sub 1 and 2 is equal to 2. Now, for the cofactor on the first row and second column, we are getting rid of the first row and the second column. We end up with this 2 by 2 matrix, plus A sub 1 and 3, the cofactor on the first row and the third column. A sub 1 and 3 is nothing but 1. And to get C sub 1 and 3, we're getting rid of the first row and the third column. We end up with this 2 by 2 matrix. Very good. So the determinant of A is equal to A sub 1 and 1, which we already know is 0. And C sub 1 and 1 happens to be -1. It's just the determinant of this matrix multiplied by -1 to the power 2, which is just 1, plus A sub 1 and 2, C sub 1 and 2. A sub 1 and 2, as we know, is 2. C sub 1 and 2 is 5. 3 times 1 is 3, minus 8 is 5. But remember that here you have -1 raised to power 3. So -1 times -5 gives you +5. Now, A sub 1 and 3 times C sub 1 and 3. This entry is basically 1, but to calculate the cofactor on the first row and third column, you're finding the determinant here. 3 times 0 is 0. -1 times 4 is -4. And remember that here you have -1 raised to power 1 plus 3, which is -1 to power 4, or just 1. So that's how you end up with 4. If you do the algebra, it is equal to 14. So the determinant of this matrix is 14. Please note that you could expand with respect to the second row, with respect to the third row, or you could expand using any columns here as well. The final answer is going to be the same.